Hello, Tom for Every Step Calculus, EveryStepPhysics.com. This is another nonsense problem by calculus sent to me by a student. I would imagine it never would appear on a test, but I'm going to do it anyways, regarding an arc, the arc length, and the unit tangent vector. Okay, so let's do it. Index 8 to get to my menu. We're going to scroll down here to arc length in RT. You see the RT here? That's a position vector. A vector has magnitude and direction. In this case it's tangent, so therefore whatever curve this turns out to be on a graphing, which I don't know how to graph it, but somebody made this function here, some mathematician or person made this function, and they're trying to convince us that this solves stuff in life, and I say it doesn't. I say it comes up with a number, which we'll show you, like this number right down here. It comes up with units, as if that was important to anything, and it's also one number. It's like taking 6 times 7, coming up with 42, and saying, hey, there you see, that's the orbit around Neptune or something like that, you know, some wild statement. So anyways, let's do it. Arc length in RT. We're going to choose number 3, RT. I have programmed the X and Y values also. And I've already entered these to save time, okay, all these functions, but you're going to press alpha and put every one of these variables in here, okay, exactly like you see it. Make sure you put times sign between the t, etc. But I've already added them. So here they are. 2 times t times cosine. Not this right here, I guess, but the original function, this one here, okay? And minus t, etc. So I always show you, you can change it if you want. I say it's okay. And we're going to do number 4, arc length. Okay, you can do all these things with what you've entered here. We're going to do, and here's the formula. You write this stuff down in your paper for your test or homework or whatever. L is length of an arc. It's really a definite integral, and then it uses the magnitude of the derivative of RT, of the RT function, to come up with this stuff here. And I show you all this. You just keep writing on your paper, putting it down. You look like a genius. Now x of t is equal to, remember, I is x, j is y, k is z. Okay, those are the parameters that they give us. So the derivative of x of t, this one right here, is this right here, 2 times cosine of t. I'm not going to go through each one of them because it takes too much time for this video. And here's yt, the next one, minus, right here, minus 2 times t sine of t. Derivative of that is this right here. Of course you knew that, didn't you? You can pull that stuff out of the air just like anybody can. Here's z of t, here's this right here, and that turns out to the derivative is 2 times the square root of 2 times t, okay? Now we're going to find the magnitude. We have to square all this stuff, and here we have the integral here over a and b, that range, and we're going to put in the range, okay? So I haven't programmed that, so we're going to go alpha 0 for the value of t, and the upper range is alpha second pi. Okay, so I show you, this is the integral we're doing with regard to t. I just put that in there in case you made a mistake on the range. So x prime of t is equal to this, and then we're going to, so then x prime of t squared is equal to this right here, okay? Same thing with yt. Here's the square of it, and here's the square of the z parameter, k. So now we're going to do it over the range. We got that all in here. We're still doing the integral of this all stuff, okay? You notice we got the square root of this here, okay? Square root of this, remember when you do an integral of a square root, you change it to half, exponent half right here. So here's what we're still completing. And of course the integral then is 2 plus 1 times the absolute of t plus 1, okay? And at t equals 0, the problem is you put 0 in for all the t's in the answer for the integral, we get 1, and for pi we get pi plus 1 squared. Upper minus lower, always, when you're doing this with a range, a definite integral, and equals here, right here, so this is the answer. Pi squared plus 2 pi. Now this is the answer that they get here on the right? They've given you the answer, okay? So it's 16.153 units. Now, what does that mean? I mean, you know, it doesn't mean anything to me, it doesn't mean anything to you. It's completely irrelevant. You're not going to use this to go into space with, let me tell you, okay? So this is the length of this unit tangent vector, okay? Now we're going to do more calculation. We're going to go back here, number 1, and we're going to scroll down here to unit tangent vector. Unit tangent vector is given, I'm against teaching this stuff, but I gave you a little hint of what you're talking about here. And of course the length is 1 in a unit tangent vector, okay? You can read that in your spare time. And here's the formula. Unit tangent vector is written just like this in all the calculus books. Derivative of RT is over the magnitude of it. And I show you what you're doing here. Here's the derivatives of each one of those, I, j, and k, and the magnitude, how you come up with that, okay? And so we're going to do the derivative of this. That equals this, just what we found before. We're going to do the magnitude right here. Of course, this is the numerator, this is the denominator. We're trying to, and here's the answer. Now you can see the answer that they have, 2 times cosine of t minus 2t sine of t. Okay, that's this one here. This one here, over here for the j is minus 2t cosine t, 2 times sine of t, okay? And it's all over 4 times t plus 1 squared. Now they took the square root outside the radical sign. But no problem. Go to my site, buy my program, they're only $40. And you'll be able to do all this stuff forever. You notice when this is the greatest notebook ever, in the calculator here, because my brain tells me, why would I ever study something hard and not write it down somewhere where you could refer to it in the future? Well, I programmed it so in the calculator so that I can actually do the problem no matter what variables they get. So think about buying my programs and you'll pass calculus. You'll get 6 or 7 problems right in any test compared to the guy sitting next to you or the girl sitting next to you. And because it's all scored on partial credit in the class curve, that's all you need to pass the class. And I never wanted to get A. I did get A's in calculus, but I never wanted to. I would have got a D. I don't care. Just get me out of there. Don't ever let me touch this stuff again, okay? Hey, have a good one.